Data distributions are shown for the quality of a farm's red apples at different points in time during the harvest season. So one distribution shows the apples in early May. One shows them in late July. Notice these distributions are both skewed. It says which summary statistics should be used to compare the two data sets and why. So if you read these statements, we can automatically just eliminate a couple of these because A says that the data sets are normally distributed. They're not, they're skewed. And so does C. So we know it's between B and D. And here's the deal with skewed data sets. With a skewed data set, this peak right here is the mode. The median gets pulled off a bit, and the mean can get pulled off quite a bit, pulled off of that peak. So on this one, it's going to be mode, median, and mean. So what I want you to notice is I don't know exactly how much this mean is going to get pulled off. Sometimes it can get pulled off quite a bit. These two means actually look about the same. The mean value is about the same. And so just looking at the means, if that's all I gave you, you wouldn't be able to tell the difference between these two data sets if you weren't looking at the distributions. So we wouldn't want to use the mean to compare these two data sets. And the standard deviation, I know we don't know a whole lot about standard deviation, but what you should remember about the standard deviation is it's a measure of spread, and it's centered around the mean. So the standard deviation might be something like this. That's my standard deviation. Symbol is a lowercase sigma, and it's centered about the mean. So since it's centered around the mean, we wouldn't want to use it to compare these data sets because the mean is really the same. Could be the same for both of these data sets. So D says use the mean standard deviation, and B says use the median and interquartile range. So, and the data sets are skewed, not normally distributed like A says. So the correct response is B.